let's start off by making a histogram using a scatter plot. First things first, the histogram and the scatter plot switches in terms of their x's and their y values. So your sales here on the side will actually be on the bottom here, and your temperature will actually be here, up and down. And now what we want to do is we want to create our frequencies. We'll do our histograms with frequency. So 100, 200, 300, 400, all the way up to 700, 400, 500, 600, and 700. What we first do is we want to count from 0 to 100 how many dots there are. There are none, so there will be no histogram frequency there. From 100 to 200, I'm going to cross out the dots as we go. This is 1. So if I went up and down like this, if I count the most, 1, 2, 3, 4, 5, so this will be 1, 2, 3, 4, and 5. So from 100 to 200, that's 1. From 200 to 300, that's also just 1. That's 1. From 300 to 400, that's 1, 2. So that's 2 here. From 400 to 500, that's 1, 2, 3, 4, 5. So all the way up, down. 500 to 600, that's 1, 2 dots. So that is 2. So here. And then from 600 to 700, that has only 1 dot. And that is how we would create a histogram from using our scatter plot. Let's talk a little bit more about our scatter plots, and more specifically correlation and association and causation. Okay, so here, if I looked at this original scatter plot, let me erase all these here. If I looked at this original scatter plot with temperature of day and sales, I can see there's actually a pretty strong and here's where I want to be careful between correlation and association. So this is actually sells for ice cream, right? Ice cream. Since they are both variables that are quantitative variables, right? Temperature is a quantitative and sales are quantitative. We can say there is a correlation, and this one has a pretty strong correlation. So yes, there is a strong correlation here. However, we have to be careful about, right, strong correlation does not necessarily equal causation, right? Does not equal causation. So just because it gets hotter doesn't mean it causes the clients to come to buy more ice cream. There might be a correlation, but it is not a causation. That is something that we should never do in stats specifically, to say this causes that. It takes a whole lot more to say specifically this causes that. There may be a strong correlation, but there may not be a causation. Just like, if you said in terms of, let's say, medical diagnosis, right? People who tend to have heart disease also tend to have diabetes, but the diabetes doesn't necessarily cause your heart disease. There's a strong correlation, not necessarily a cause. It could, that's why they say could lead to, but not necessarily 100% that is your cause and factor. There's a whole other hosts, that could contribute to you getting one or the other. Also, let's talk about linear graphs. Let's say if we had a linear if we had a scatter plot, and it looks kind of like this, right? If we had this, even though in our world, in normal math world, you look at that and you're like, oh, that looks like a parabola. There's probably your R value. You think your R value is pretty high. Remember, our R values, the tighter to a line it is, the higher the R value. You think this is probably a 0.8 or something. However, in this circumstance, this case, we have to be careful with graphs that look like this, because when we think about the R values being high, we think about a linear relationship, so a line, and not a parabola. So something like this would have an R value, but something with a parabola is going to have a low R value, like a 0.00, 4 or something. Always be careful with those things. Next is we have to think about things that can never be correlations. Okay, so if it is categorical can never be correlations. Correlations are between two quantitative variables. So basically, you cannot say, for example, the type of material fabric for a design of outfit causes, that there's a correlation between the type of material versus the price of a designer outfit. Cannot do that. The type is a category. We cannot link those two together. Okay, so when you are doing scatter plots and correlation and causations, I want you to think very carefully about what they are going over, and whether or not it is one possible, what type of variables we're working with. Is it categorical? Is it quantitative? And then if it is, does the relationship with the R value, does it make sense in this case?